The second method that can be used to convert entire into mixed radicals uses prime factorization. So we're going to start by prime factorizing 45. So I'm going to break this into 5 and 9. 5 is prime, so I'll stop there. And then I'll break 9 into 3 and 3. Those are both prime, so I'll stop there. Now you're going to replace 45 under the radical sign with its prime factorization. So 3 times 3 times 5. Now you're going to identify any pairs under the radical sign. So I see we have a pair of 3s. So for that pair of 3s, I'm going to put a 3 outside of the radical sign. Then we're left with this 5. So I'll put that under the radical sign. So what this tells us is that the square root of 45 is equivalent to 3 square root 5. The reason that this method works is actually because of perfect squares. When we have a pair of numbers, it's technically like a perfect square. So here we have 3 times 3, which is 9, and the square root of 9 is 3. For the next one, let's go ahead prime factorize 80. So I'm going to break it into 8 and 10. This breaks into 2 and 5, which are both prime, so we can stop there. 8 I'll break into 4 and 2. This is prime. And then I'll break this one into 2 and 2. So now we want to replace 80 with these 5 numbers. So there they are. Now I want to identify any pairs of numbers that I have. So I have 2 and 2, that's a pair. I have 2 and 2. For every pair, we're going to bring one of those numbers out. So for this 2 and 2, we have 2. For this 2 and 2, we bring out a 2. And all we have left under the radical sign is this 5. So simplifying that, 2 times 2 is 4, square root 5. So off to the right here, I've created my prime factorization tree for 343. So I'm going to replace 343 with 7 times 7 times 7. So I have a pair of 7s. So for that pair of 7s, I'll put a single 7 out front. And all we have left under is the 7. And just to reiterate why this works, 7 times 7 is 49, and the square root of 49 is 7.